Hello YouTube, welcome back to my channel. So in today's tutorial we're going to go over confusion matrix. So in the last tutorial we looked at a classification model called a logistical regression model. So from there we were able to draw a confusion matrix, but I was not able to explain in depth to you because that tutorial was not meant for a confusion matrix. So in this tutorial we're going to explain confusion matrix. I know that I promised that we're going to do a classification of the high-risk data set, but I think it's important that we look at the confusion matrix before doing that project so that we can apply that knowledge inside of that project. Okay, so let's get started. So in the last tutorial we were able to draw something like this, where these are the truth values and these were the predicted values, right? So this is how a confusion matrix looks like, and this is how to draw in the last tutorial. So let's go ahead and actually see define what a confusion matrix is. So a confusion matrix is just a table that is used to measure or describe the performance of a classification of a classification model or a classifier. That's what basically a confusion matrix is. So let's see how a confusion matrix looks like whenever we draw it using the terminology. So these are the actual values, right? The labeled values from our data set, and these are the predictions that were not made by our model. Okay, so on the main diagonal we have the truths, and then on the non-main diagonal we have the false. Okay, so let's start by discussing what this cell first. So this one is a truth negative, right? TN stands for truth negative. So truth negative is occurs when our model predicted the actual value is 0 and our model predicted 0. That is known as the truth negative. So our actual value is 0 and our model predicts 0, we get a truth negative. Okay, a truth positive is when the actual value is 1 and our model also predicted 1. So that's what is known as a truth positive. So a false positive, which is FP, stands for false positive. So a false positive is when our model, our actual value, our labeled value from our data set is a false, right, a 0, but our model predicted a positive, a 1. That is known as a false positive. So a false negative, you can actually guess this at this point, is just when our model, the actual label is 1 and our model predicts the answer to be a 0, right? So makes a prediction of 0 while the actual label is 1. That's what is known as a false negative. Okay, so let's jump into the basic terminologies and then we start looking at the formulas. Okay, so we first go by discussing what a truth positive is. We've already looked at it, but let's just look at it one more time. So a truth positive is the number of times we predicted 1 and the actual value was a 1, right? So this is the number of times you predicted 1 while the actual value was a 1. So whenever I look at this the root confusion matrix, right, these are the truth positives, right? We're talking about truth positives in this section, truth positives. So truth positives are these ones over here, right? So truth positives are the number of times our model predicted true while the actual value was also true. So we can see for for this model, 67% of the time our model predicted 1 and the actual value was a 1. So that is known as a false truth positive. So now let's look at the truth negative. So truth negative is the number of times our model predicts 0 and the actual value was also 0. So you can see that for 7 times our model made a prediction of 0 and the actual value was also a 0. So our model the actual value is 0 and our model predicted 0 for 7 times. So that is known as a false truth negative, rather. So let's look at the false positives. So false positive is the number of times our model predicted true while the actual value was a 1. So our model predicted true, so the prediction was true, but the actual value was a false. That is what is known as a false positive, right? So now let's look at what is a false negative. So a false negative is the number of times our model predicted false while the actual value was a true. So this one right here, the actual value was a true, and our model predicted 0 for 0 times. So this model actually did well, but you can see when it comes to false positives, our model misclassified a data which is supposed to be 0 and our model classified it to be a 1. So the actual value was a 0, but our model made a prediction of 1 for 6 times. And if you look at the false negatives, so these are the false positives, and if you look at the false negatives, for 0 times our model predicted the actual value was a 0 and the actual value was a 1 and our model made a prediction of 0 times. So that was actually good. So then the number of the main diagonals, so whenever building a model, you want the truth positives and the truth negatives to be bigger than the false positives and the false negatives. That will give your model that makes sure that your model is not misclassifying data. Okay, so now let's look at the evaluation matrices. So what are these? These are just rates that help us to make sense of the confusion matrix. These are just a set of formulas and definitions that help us to make sense of our confusion matrix. So let's begin by discussing what is accuracy. So accuracy is the ratio of the correct predictions to the total number of predictions made by the model. So when so you find the total number of truth positives and truth negatives, and then you divide it by the sum of the truth positive, truth negative, false positive, and the false negative. That is when you have the accuracy of the model, right? So in general, how often what accuracy try to answer is that in general, how often is the model prediction correct, right? So if you have an accuracy of 90%, then for 90% of the time your model is actually correct. So that's what accuracy means. So let's look at misclassification. So we always assume that our model classification accuracy is always 100%. So we take the 100% minus the actual accuracy of the model, the result that you get from finding the difference between that 100 and the actual prediction accuracy of the model is what is known as misclassification. So you can also find by using a formula. Just take the false positives, the sum of the false positive and the false negative, divided by the sum of the false positives, false negative, false positive, and the false negative as well. So the ratio, the answer that you get from there is also known as a misclassification. Okay, so I hope it makes sense. So it tells you what this matrix answers is that in general, how often is a model prediction wrong. So if you have an accuracy of 90%, then your misclassification will be 100 minus 90, which you get 10% of misclassification. So for 10% of the time, your model might be wrong, right? So let's move on to precision. So precision is the ratio of the truth positives to the truth positive to the sum of the truth positive and the false positive. Okay, so it deals with just the right column of the confusion matrix. So whenever we have a confusion matrix, the precision is always concerned about the right column, right? The false positives and the truth positives. So if precision is the ratio of the truth positive divided by the sum the ratio of the truth positive divided the ratio of the truth positive to the sum of the truth positives and the false negative and the false positives rather. So the sum of the truth positive and false positives, so the ratio of it, right? That's what precision is all about. So this tells us how often how often is the model correct when it predicts a truth value. So whenever we want to check how often is our model correct, whenever we predict a truth value, you need to look at the precision. So the precision answers the question of how often is a model correct whenever we are predicting a truth value or a positive value, okay, a positive label. So now let's look at the sensitivity recall, or also called the truth positive rate. So the truth positive rate is the ratio of the truth positive over the total number of yes within our data. So it's the total number of truth positive divided by false positive and the false negative. Okay, so this one just focus on the bottom row of the confusion matrix. So I divided by the truth positive, it finds the ratio of the truth positive to the sum of the truth positive and the false negative. So it's only focused on the bottom row of our confusion matrix. And what this model, the question it tries to answer is that out of all the actual yeses or actual truths, how often does the model predict yes? Okay, so out of all the positives, how often does our model predict positive? This is what the truth positive rate answers. Okay, it's also called the recall or sensitivity of the model. So now let's move on to false positive rate. So false positive rate is just the false positive over the truth positive and the over the truth negative and the truth positive. Okay, so the ratio of the false positive to the total number of negatives within the data set. So you just take the truth positive, the false positive divided by the total number of negatives within our data set. So that's what it does. So it focuses mainly on the top row of our data, right, where we have the truth positive and the truth negative. So it focuses on the top row of our data. So it's known as the false positive rate. So the question this matrix answers is that how often does our model predict a yes when it's actually a no? Okay, so when we are trying to see how often our model predicts a yes when the actually is a no, we look at the false positive rate, right? So now let's look at the truth negative rate, or it's also called it's really hard to pronounce this one, but it's called specificity, right? So specificity of the model. So this is the ratio of the, so this is actually a ratio, not ration. So ratio of the truth positive to the total number of negatives in our data set. So you just take the truth positives divided by the truth positive and the false positives. That's how we get the the truth negative rate, or the specificity of our model. Okay, So the question, this is really hard to pronounce. The specificity of a model, the question it tries to answer is that how often does our model predict no when it's actually a no? So that's what it tries to answer. So let's look at the prevalence. So the prevalence is the total, how often does a yes occur within our data set. So we take the actual yeses and then divided by the total number of samples within our data set. That's how we get the prevalence. So let's look at the F1 score. This is very, very important. So this is also known as the harmonic mean of the precision and the recall. So the F1 score is 2 times the ratio of precision times recall to precision, the sum of precision plus recall. So we just take 2 times the fraction where we have the numerator as the precision times the recall, and the denominator as the precision plus the recall. So that's what F1 score is. And F1 score is very, very important that you know what F1 score is. It really tells us a lot about our model. So let's look at the null rate. So for example, you have a data set, right? And your data set is highly unbalanced. For example, let's say you have 1000 rows, and out of that 1000 rows you have 90 rows that have label of true, and then the rest 100 rows have a label of false. So if your model was just blind and then you just code something that was always predict true, then for 90% of your time your model will be correct. So you might be celebrating that my model is really doing well, but it's actually really doing bad. So that's what the null error tells us. So it's often, this is how often the model prediction will be wrong if we always predicted the majority class, right? So if you always predicted true, and for 9,000 records your model is true, and then the rest 100 is false, then if you just predict the truth values, right, which is the majority class, then your model will be correct 90% of the time, and you only be wrong 10% of the time. So you might think that your model is actually doing something great, but it's actually doing wrong. So you can read more about this on the paradox accuracy. I'll just leave this notebook. I'll leave a link in the description where you can find this specific notebook. Okay, so this is all I wanted us to discuss. So let's look at the assignment that we have. So I've shown you this confusion matrix earlier, so just take this confusion matrix and use it to calculate the precision, the recall, the F1 score. Just do it manually with your pen and paper and a calculator, so that you can really understand what's going on in other times when you try to evaluate your model. So this is my assignment for you. You just have to use this confusion matrix to calculate all the matrices that we discussed on earlier. So that's all I wanted us to talk about in this video. Thanks for watching. If you find this tutorial helpful, please kindly like and subscribe to my channel. That is one of the ways you can help me. So thanks for watching. Keep safe. See you in the next tutorial.